Hey programmers, welcome back. Right now I want to work through the code walkthrough for this intersection problem. So let's jump right in over here. And we'll start with just our brute force solution. I think it's still valuable to at least implement the brute force at one point in your life. And then you can kind of just have the optimal solution under your belt as well. So I'll just start by iterating through the elements of the first array, so A. And I'll use a for of loop in JavaScript. So I'll say for let, item of A. So if you're unfamiliar with the for of loop in JavaScript, it just iterates through every element of an array in order. So as we can imagine, let's say our array A was this array. In the first iteration, item, so I'll say item over here, item is going to be 4, next iteration is going to be 2, and so on. So it just iterates in order of that array. And to actually get going on this one, I could nest an additional loop if I wanted to, but I think overall I'll just use a built-in function that I know is still technically I'm going to use a loop under the hood. So for that item, I'll check, is that item included in B? So does B.includes that item? And if it does include that item, then I know that I have a common element, right? Because the element's definitely in A, and it's also in B. So it must be in both. So then I'll form my output array, and I'll call it the result. And when I find such an item that's included in both, I'll go ahead and just push that item into my results. It's just result.push item. Again, you could have also just written a manual, a nested for loop, but again, there's technically a loop inside of the implementation of includes. So this will do just fine. Then after the for loop, I'll go ahead and return the result. So this, like we mentioned, has an n times m complexity because let's say n is the length of A, so this for loop is definitely going to have a runtime of n. This includes call evaluating would cost us m iterations. So let's run these tests, and we expect some of the latter examples to time out here. Yeah, looks like example 4, not quite fast enough. We get a timeout. If we look at the test case for that one, test 4 looks like they go ahead and test roughly 50,000 elements. So it's kind of no mystery that this solution fails on that particular input. And so let's go for the optimal solution now. And the key is to use some sort of like a hashed data structure in your language of choice. I'm going to use a JavaScript set. So maybe you're unfamiliar with sets. Maybe I can just demo that really quick. So if you have a set, let's say I start with an empty set. So I'll say, I don't know, my set equals a new set. So some JavaScript syntax here. I'm going to insert, we'll say, some items into my set. So in general, methods I'll find useful are add and has. So I'm going to add the element, 3, then I'll add the element 5. Let's say I also add the element 3 once again. We'll notice a few characteristics of our set. And I'll start by just console.logging what my set looks like. So I'll run this just as a file, so I'm not running the tests right now. So notice that I see my set printed out, it just has the elements 3 and 5. You can already notice that set, the elements inside of it are going to be unique, right? So I only see 3 appearing once technically, but I can add it as many times as I want. But it's really just one instance of 3 inside of my set. I'll also quickly demo the has method. So just how I check for membership inside of my set. So my set.has 3, that should be true, has 5, that should be true, has, we'll say 12, that last call should be false. So we'll check for the output here. Good, true, true, false, exactly what we expect. And the upshot of this is doing this has operation is constant time, right? It's O of 1, whereas doing array includes is O of n. And so just by using a set here, I can get a much faster runtime. So let's start with, we'll say part 1 of our algorithm. So we'll keep the result, we'll use that later, but to start, I'm going to create we'll say a set of items. So I'll say const items, and this will technically be all of the items of my first array. So I'll make that a new set. Maybe I'll move this up a little bit. And then inside of this for loop, I'll just add every item into that items set. So I'll say items.add that single item. Cool. And so now separately, what I'll do is iterate through the elements of B. And what's really important to notice is technically set.add also runs in constant time, just inserting a single element into a set. So I'll start another loop. This is going to iterate through an item of the second array, B, and I'll just check, is that item included inside of the item set? So one thing I can say is possibly, if items.include, maybe I'll give it a pretty distinct name here. Maybe I'll call it just the element. So if the item set includes this element, then it's a common element because it's definitely in both of my input arrays. And so then I'll add it to my results. So then we'll say result.push, because result is an array, result.push your LE. Cool. And taking a quick lay of the land over here, you can already see that I have 2 loops still, but they're not nested. So this is going to be n iterations followed by m iterations. And then I don't want to include here. That's a typo on my part. I want a has. This has operation is O of 1. So I should be able to pass the specs now. Let's give it a go. Cool. And even pass the last example over there. Nice. And there we have our nice go-to solution for this intersection problem. And we're going to be using sets quite a bit moving forward, so do understand why we choose it here. It's a very efficient data structure when it comes to checking for existence, right?